industry, So even we cannot expect the complete work. The DevOps is so vast that the NOC, previously there used to be a NOC data centers. NOC, they will call it as, like, where the monitoring, these all people used to do in that NOC. Now they change it to that DevOps. The name under it came under DevOps. So it's so vast that the roles and responsibilities will differ from each and every, uh, in the company itself, it differs. So yeah, I understand. So you can upgrade your career, and easily. I'm going to show you how you can correlate the things, and how you can easily upgrade your career to the next level. And you can even see, when we are giving an interview, for example, when we are giving an interview for the companies. So what do you do is, what we have to do is, we have first question what they ask is, have you built the monitoring? When we say that we had done the monitoring, they're not satisfied with that. So they will expect that we have to build from scratch. So that is what the expectation will be from the interviewer. And also they will ask, like, for example, you told service now, and what is your monitoring tool? Sorry.
Tool, there is nothing like tool in from AWS. We'll monitor alarms from CloudWatch.
CloudWatch, okay.
Mm.
Okay. You will get notified, and you must be having PagerDuty as well, right? No.
No, for the incidents or tickets which will receive any utilizations related, we'll manually check through CloudWatch or logging
Okay.
into the server.
Okay. Got it. Got it. So you have access to the Linux servers and Windows servers, is it?
Yes, we have.
Great. At least, yeah, you can go and you can troubleshoot, and you can
Yes.
resolve the issue
Yeah,
seamlessly.
yes. Previously, new account, recently we are deployed in a new account. Whereas
Okay.
old account, there is no, more manual work. Whenever we receive incidents, they will be assigned to RBA Auto Heal.
Yeah.
Only for high priority incidents, we need to manually assign. If the bot is programmed in a way that if utilization is under threshold, means it will only automatically resolves for
Okay.
few servers.
Got it. Automatic healing will be there.
Yeah,
Yes.
RBA Auto Heal.
Auto healing. Yeah.
So there is no that much account. That is a stable account now, which we are working for our
I got it.
old project.
I got it. I got it.
In this new account where we are working for now, the GCP, AWS, and Azure are also involved. It's a big account, but
Got it.
as of now, we are working in just Azure and AWS only. We are managing.
I got it. I got it. So
So I.
easily, see, what I'll do is, first thing what I'll do is, for everyone who are upgrading your career, I'll give you a kind of script, or you can say, or I can give you some kind of, I mean, what you have to speak. Introduction. You can say introduction. For example, the first impression is when you introduce yourself to the interviewers, right? That's where the first impression comes in, right?
Mm.
So for you all people, what I'll do is, like, how many people are there? I'll give you all the people according to your JD and according to your projects, according to, not according to your JD, according to your projects and according to your work. I'll prepare for everyone one nice kind of introduction, you people. So in that, it consists of CACD and all. So when you prepare that introduction, and when you go to the interviews or when you speak with the people, so you can get most of the points in that, and it will be very crisp, and it will be easy for you to kickstart when interviewer asks. And so that's a good thing, so easily you can, from after the introduction, they will start questioning you, right? So those and all we can, we will discuss what questions they will ask, and for example, for each module, for example, today Linux class is there. So I think you will be aware of Linux, right? You will, I mean, you had worked on Linux, and you will be bit aware of Linux, what and all, what
The,
it is.
the basic commands I am somewhat aware.
Yes. So we'll discuss. For example, what we'll do is, for example, for every class we will discuss the Linux interview questions, what we'll ask in the real time, right?
Yeah.
And for every end of the module, for example, end of the module of the Linux, what we will do is we'll do a small project. Yeah, for everyone. So we'll do a small project. So where you will be installing a Linux machine through EC2, and you will be deploying an application. And for example, after deploying, you will be troubleshooting that application. Okay. So for example, you say Nginx or Tomcat. So you will troubleshoot that. For example, I'll after installing the application, that is first project, and second project is I will do some kind of I'll do some, for example, you say in Nginx. So I'll remove some configuration in the Nginx, and I'll give it to you. And you people troubleshoot that. So in that way, you can do in that way, what you can do is you will be getting real issues, and also you can go through ChatGPT or whatever you want, and you can get some of the commands which are troubleshooting commands you will get. So in this way, you will be perfect in the interview. You will be get you will get perfection in the troubleshooting. You will get perfection in the Linux. So that is what. And also, I request you, all the people, whatever I teach in the class, just go back and just practice the Linux commands, whatever I tell you in the, not this class and next class, whenever I'll tell you. So just practice those commands. Whenever you practice those commands in the terminals, so you will be familiar with them. You will be comfortable with them. And whenever the interviewer asks, you can easily cope up with that, right? So that's my request for you people. Just whatever we teach in the class, just you go back and you just practice for half an hour, not more. Not more than that. I'm not asking even for 1 hour also. Just whatever I'll teach you, I'll share you the notepad. I'll share you the material, whatever it is, and you just go back and you just practice that. That's it. Okay. So today we'll start the class. Yeah. Today we'll start with Linux introduction, and this is our first class, right? And as I told, so hope you can see my screen, right? So as I told, see, the first thing we'll discuss the we'll discuss the topics, and we'll go by the interview questions. For example, for these particular topics, what are the interview questions we are going to get? Maximum interview questions we can expect. So those things we will discuss, and followed by Q&A. Okay, right. So as you all know, Linux is something. Linux is a kind of OS, operating system, and it's similar to your Windows desktop, right? And the derivation, it started with the Unix. Unix is something an open source, right? From the Unix, it came to GNU, and from the GNU, it derived to Linux. So what happens is when you get an open source, yesterday I have discussed. So the main difference between they will call it as an open source. What is an open source? Open source is something kind of, you will get the code, and you can modify your code accordingly, and you can build your OS according to your according to your custom requirements, right? So Unix is something, uh, it was formed by kernel modules and all, and you can take the source code and you can do the modifications and you can work, I mean, you can make according to your requirements. And that's where it got famous, and that's where it got, people started using it. And coming to Microsoft, for example, your desktop or whatever, your Windows. So these and all are managed by Microsoft, right? And if you got any issues, you have to raise a ticket with the Microsoft. It's not an closed, I mean, it's not an open source where you can debug, right? And the main pros I can say, Unix, Unix or Linux, we can say Unix are, these are uh, less cost. The cost associated with is less, and Microsoft is bit costlier because, as you know, this is cost, I mean, license oriented. And again, so Unix is kind of used by the production environments or used by the enterprise services, enterprise people. For example, what do you mean by enterprise? Enterprise is something kind of companies, or enterprise is something kind of the small startups, we can say. And it's a kind of, I mean, if you want to run a company or anything, most of the people prefer Unix only because of the security reasons, and also the consistency, reliability, the uptime. So these all were taken into the consideration, and they are, most of the people are installing the Unix. And also, why Unix is important is most important, I'll tell you. For example, you use the phones, iPhone, or you use the, I mean, Android. So what do you think in the backend is there? The OS, operating system. So it is Linux, right? And if you take Mac OS, what is there in the backend? So it is the Linux. So Mac OS is something Darwin, right? So you see the, I mean, I mean, they had derived from the Unix, and they had customized according to their requirements, and they had named it as Darwin. And in the same way, Ubuntu. So they had, I mean, they had got the source code from the Unix. I'll, they had got the source code. One second, I'll just show you the diagram so you can understand this. So first is Unix. So from the Unix, they derived into this that, so they derived into, so first is where on okay. Unix, and from Unix it got derived into, so we can say, distributions. So from the Unix, it's a kind of operating system. Okay, it's a kind of parent, you can say. Okay, parent. And from the Unix, all the OS, I mean, for example, Ubuntu, and I think I have written here. Okay, so distributions I have written. So we had Ubuntu, Red Hat, Ubuntu, Red Hat, Fedora, and Amazon Linux, Amazon EC2, Azure VM. So these all got derived CentOS. So these all got derived from the Unix. So what they did, so they took the licensing. For example, it's an open source. They took the code and they modified the code and they made it available. I mean, they created their own flavors. We can say they created their own and they released into the markets. So why don't we, for example, you can ask, why don't we use directly Unix? So why? Because the problem with the open source tools are you will not get the support. So you, for example, in Microsoft, you can, for example, they support 24/7. That is very much important in the when you use for a server or when you use in system when you use systems when you use I mean when you use for your enterprise level, you need something support which is consistent, and whenever you need support you need that. So the only problem with the open source tools are you cannot get the support. You will not have the support because there is no one to support you. Open source is something you go and contribute and you go and develop something and someone can use whatever you develop, right? So you cannot expect the support from them. However, you have the Slack overview and you have some support channels, but those are not kind of what do we, for example, you take the GitHub. So there are some support channels where you can post your query and you can get the support from them, but it's not like immediately you want the support. For example, there is a production issue. So do you wait for the support channels to respond to you whenever they want, they will respond. So do you wait that? No. So what you need is you need some 24/7 support like Microsoft. So that was the reason these people, what they have done, these companies, what they have done, they took the Unix as a source code and they had developed it. These people had developed it and they have released their operating system into the market, and those are free, for example. So you can use these things. Okay. These are cheaper compared to Microsoft, and these are perfect to use in the production systems, and there is an uptime. These are consistent, these are resilient. So that is how the Unix came into the limelight, and people started using it. And Fedora, CentOS, and if you even take HP Unix, and they will HP people had took the Unix and they have made it as an HP Unix, and Oracle people had took the source code and source code from the Unix and they had derived it and they told it was Solaris. I think people which are you people had heard about this. If not, Solaris is something Oracle built. So that is how people took this Unix and they had derived it, and they had created their own custom operating systems, right? And coming to distribution. So what is a distribution? So will we say it as an it's a kind of distributions or distros? What do you mean by distros? So anyone in the class, what do you mean by distributions? So distributions, anyone? So here you can see. So distributions are something, it's a kind of package, you can say, right? And kernel, and for example, the OS, and in the OS, it consists of the package manager and the desktop environment and utilities and kernel. I'll tell you what is kernel is. And these and all combination, we call it as a distributions. And as I told, we have major distributions, that is Debian, Red Hat, SUSE Linux, and Fedora, and we have HP Unix. So these and all comes under distributions, right? And now I'll tell you the Linux architecture, how it works. So I'll tell you, like, for example, in interview, they might ask, so how do you choose your distribution? So how do you, for example, you take the EC2 instance, and how do you uh, choose your EC2 instance? So this is one of the similar, this is one of the common question what they will ask if they want to test you, if they want to test the real time. I mean, whether you are real time, whether you have hands on. So what they will ask is, I mean, what type of EC2 instance you have worked on. So you might say, use first thing. I mean, the people will go wrong here, and they will say T2. T2 is something no one will use in the environment. Like, I mean, most of the companies will not use T2. There are there are MC servers, C4, M type servers, and you can. So these are some of the type of servers you have to give answer in the interview, so that the questions will be what is M type, what is C type. So the discussion will start, and you can explain them, and you you choose one type of servers apart from T. T is something free tier, and you cannot choose that. And in the real time, you can choose some other servers, and you can answer, and that's how you can get some kind of confidence that you have hands on to the interviewer. And I'll tell you one thing. See, interviewer getting the interviewed is, you will get interviewed for 1 hour, and how you, in that 1 hour, how you manipulate in the sense how you answer, how you attract the interviewer is the main question. I mean, is the main point, like how you attract the interviewer and how you crack the job, right? So that 1 hour is a kind of crucial thing. How you speak, how you manage, how you interact with him is something crucial, right? So coming to the point, so that is how you, whenever someone says that how do you uh, choose the distribution, so how do you select which one you have to go with the, for example, uh, you want enterprise production, so most of the people will choose Red Hat enterprise clusters. For example, Red Hat, if you say, if you take about Ansible, so Ansible Tower was built by Red Hat, and Ansible Tower is completely, is used for managing the Ansible instances and Ansible playbooks and all, right? And for example, Ubuntu. So most of the Ubuntu is used for cloud images and backend CI/CD labs, and in that way, right? So that is how you choose the distributions for the DevOps. And coming to the Linux, so any doubts till here, guys? If no, I'll continue further. So this is important. So this is very much important. See, Linux system architecture is different from the Windows. Windows is something you can see everything in the GUI. In the backend, what will happen, you doesn't know. Everything is an OS, operating system. You understand that. You correlate Windows to the Linux. When I'm teaching you, correlate Windows to Linux, and but in the Windows, in the GUI is something graphical user interface. You can visualize everything. For example, this is the notepad. And for example, if you want to create a folder, what do? You go to the, you you will click on this. One second. So if you want to, for example, this is Windows. Okay. So these are the program files, right? This is called C. And if you want to create a folder, what do? You go here and you click on new folder, and it's easier, right? So for example, continue, and you create a folder, something, right? So in the same way, yeah. So you create a folder. And in the same way, you want to do some operations. For example, you want to copy the file, you want to do some operations you completely do it in the GUI. Coming to the Linux, it's not possible. So you need to do through CLI. Even though the GUI is there, and the GUI is not that feasible, and most of the people use the CLI, command line interface. For example, in the Windows as well, you can use the command line interface, and that is through command prompt. But most of the people, what they will do, they will use through GUI. So when I teach you in the class also, when I tell you the commands and all, so what you can do, you can correlate them with the Windows. Have you for that will be easier for you. For example, if I tell you, I mean, if I say hard disk, you might have seen the hard disk and all. Everything is similar. Everything Linux and OS. I mean, everything is an OS operating system. Everything is similar. For example, you can think I'm teaching you. You keep in your mind I'm teaching you something operating system which is, and just giving a top up on that, right? In that way, you can easily correlate that with the existing Linux, and it will be easier for you as well. Okay. Now, coming to the Linux system architecture. So in the backend, the Linux, what is the architecture of the Linux? Linux is nothing but Unix. Linux, we call it as a Unix. Okay. So what is the main architecture of the Unix, right? So there are three core layers. One is hardware, okay. One is kernel, one is user space. I'll draw one diagram. Let me bring this. Okay. So as I told, we have three layers. One is hardware, one is kernel, one is user space, right? So first is hardware. So everyone knows that hardware is something, the base metal, we call it as a hardware, right? First is hardware, and another one is kernel. I'll tell you what is kernel. And another one is shell. Another one is applications. Okay. So first is hardware. So this is the hardware. Okay. So what is an hardware? So hardware is something you physical resources, right? And it consists of CPU, hard disk, network interfaces or memory. So which interacts, I mean, when you, it's a simple hardware, you know, right? So, and what happens is next comes is kernel. So kernel is something, it's a core of the operating system. Okay. So it's a, we can say it's a kind of heart of the operating system. Okay. And what happens is when you interact with the shell is something CLI. You interact with, for example, in the command, I'll tell you this. So this is the shell, CLI. So we call it as an, in the Windows, we call it as a command prompt, and in the Linux terminal, we call it as a shell. So there are, I'll tell you what is it. I mean, I'll tell I'll speak about the shell in the coming classes much more what type of shells and all. So shell is something you interact in the sense you execute the commands, you you for example, you want to create a dust, I mean, you want to create a file, you want to create a folder. So this is where you interact. Got it? And from here, when you interact, when you, for example, when you say, hi, create a folder. So what it does, shell will interact with the kernel and kernel will say interact with the hardware and it will get executed. So it's a kind of, kernel is a kind of interpretation. What it does is from the human language to machine language, it's a kind of interpreter. Okay. Kernel is, and as I told, it is the kernel is the core of the OS. I mean, it's a kind of heart of the OS because if you in the shell prompt in the from the shell from the CLI, if you say init 6, I mean, you shut down the server, reboot, or you can say shut down init 0, or you want to reboot the server, or you want to do some operations. For example, you want to burn the firewall, something, right? So from here onwards, you when you give the commands, kernel will understand whatever you are giving it. Okay. And it will interpret and it will interact with the hardware, and it will say that, okay, uh, the user is asking to shut down the server, you go off, you shut down, or user is asking to reboot the server, so it will, you reboot the server. So something, it's the core of the OS. And shell is something, sorry, so shell is something you interact, and on top of that shell, those are applications. So what happens, you when you install an application, from the application the users will act, I mean, users will interact, right? For example, you take the website, I mean, you take a website, so www.google.com or www.sbi.com, something, any of the website you take. So in the website, you are logging in, right? So when you are logging into the website, or when you are logging into some of the banking domains or anything, so that domains, where are they hosted? They hosted on the server, right? And so that server is something, this is the layer, right? On top of the OS, applications will be installed and users will interact with the applications. Okay. So that is how. So any doubts on, any doubts here? Anyone? Yeah. So if no, I'll just go to the next one. So shell, as you know, there are uh, three types of shells what we have, and KSH, bond shell, and we have another shell. So I'll just go into the deep dive into the shells when we get it when we get into it. And as I told, kernel is something heart of the OS, and we have shell is a kind of acts as an interpreter between the user and the kernel. I mean, kernel will act as an interpreter, and yeah, and yeah, we have covered this. Yeah, common interpreter between user and kernel. So shell is something you interact. First, it's a kind of shell is a kind of user. I mean, when user interacts with the shell, so that's what he interacts with the kernel as well. I mean, in the backend, it's a kind of interpreter, as I told. And we have types of kernel. We have two types of kernels. One is monolithic kernel and another one is microkernel. So what is monolithic kernel? Monolithic kernel is something all services run in kernel space. That is Linux. Okay. So, and microkernel is something minimal kernel with user space services. So what do you mean by monolithic and microkernel? So monolithic is something, for example, we have, I can, so monolithic is something kind of, what we can say is, for example, you take file management or CPU handling or device drivers with a single address space, it's going to run. All the services is going to run in a single space. So what happens? It executes faster, but the fault resolution, like fault isolation, for example, fault isolation in the sense if anything happens wrong, it cannot isolate everything. So its fault isolation is high and processing is fast. So that is where the monolithic. So you can say monolithic applications and all. So that is what types of monolithic kernel they will use for. So microkernel is something you use for most of the services to, for example, user namespaces. You can correlate that namespaces. You can in the Kubernetes namespaces, or keeping only most of the functions, basic functions in the kernel space for kind of better security or better reliability. And but so that is what microservices we can use for microkernels. So that is what the major difference between monolithic and microkernel. So I just touch based on this. I mean, no one in the interview they will ask, but it's good to know that what is monolithic and microkernel, monolithic kernel and microkernel are, and what does kernel do? What do you what does the what are the responsibilities of kernel? So the main responsibilities are, what it does is process management. Process, what do you mean by process? Process is something when you execute, for example, in the Windows, if you see, mm, so if you take task manager. So if you see the task manager, what are these called? Applications. And what are these called? Process. Inside the applications, there are multiple processes, right? So those are called process in the Linux as well. So this process management is done by kernel. And the memory. So here 88% memory and CPU percent. So these all will be maintained by kernel, like memory allocation. For example, what it does is there is a disk and there are multiple disks, right? So memory, I mean, the memory allocation in the sense it will ask memory to, I mean, it will distribute the memory to all the disks, and it will maintain that, and it will, that is what the allocation will, it will be taken care. So these all things will be done by kernel. And also device drivers we have. So how the memory allocation will be done. So that's how the disk drives we have, IO management, input and output, error handling. So these all management, all the core components of the OS, operating system, it will be handled by kernel. For example, file system handling. File system handling in the sense, for example, you have you ever thought in the Windows, in the OS, when you create and when you insert a disk, when you insert and when you insert a pen drive, so it will ask you to format. In the first instance, what it will ask you to format, and it will ask you to bring it into the format into NTFS or something, right? So that is what the file system. Then only the file system will get to know. Okay, I need to. I need to become an alive and I need to work as an, it will allow to do read or write operations on that file system. So that is what the file system handling. So the file system handling, it's also being taken care by kernel. And the last one is inter-process communication. So inter-process communication is something between uh, we can say the networking, we can say. So for example, one application to another application, so if you want to speak with both of them, so interprocess the all communication will taken care by this kernel. So if you can see, most of the core components are going to taken care by kernel, right? So any questions on this till now? Hope you're able to understand whatever I'm speaking about and what is the Linux consists of. Any doubts here, guys? Okay. Yeah. So we'll go to the next topic, that is, as I told, the shell. So we have, so as I told, it's an interface between user and kernel, and it's a kind of interface in the sense the user, what will happen when you execute a commands and it will interact with the kernel. It's like an interpreter. And we have types of shells, like we have bash, which is a commonly used, and we have KSH, we have ZSH, and these are the common shells what we use, and no login. Okay. Okay. So these are the type of shells what we use. Most of the in the industry, what we use is these are the shells, and Bash is something common shell. I mean, uh, you can say 70% people use the Bash when they want to interact with the applications or when they want to do some operations, they will do Bash. And so I'll tell you simple thing what will happen when you execute a command. It will first what it does is it parses the command and it gives the system call. It will first understand and it will give the system this system call, that is interpreted, and to to whom it will give. It will give to the kernel, and you will get the output. After you giving it to the kernel will understand it, and it will interact with the hardware. If you want to interact with the hardware, if it interacts with the hardware. If you want to interact, if you want to get the process, it will interact with the process, memory, and device. Whatever you give the command, it will interact with the kernel, and from the kernel you get back the output. So that is how the shell works, right? So we have so hope you everyone understood till here, right? And and the last today's the last one is environment variables. So we have environment variables is a kind of vast concept. So I'll tell you, in the when it comes to the same, it is same like Windows. So you can see the environment variables here. See, so you can see the environment variables, right? So it is same like Windows, as I told. So We have path, we have home, we have user, env, we have path, we have home, we have user. And here I want to tell you one more thing. So in the environment variables, for example, if I want to execute something, if I, for example, I install an application, right? For example, you say I installed an application stating that I installed a kubectl. I mean, I installed a Kubernetes application onto the server. Okay. Kubernetes application in the sense, not Kubernetes application, kubectl, you can say command line utility or whatever. If I had installed an kind of zip, I mean, zip in the sense, it's a kind of, you want to unzip or, so that kind of utility I have installed on the server. Okay. And if you want to use, so, and yeah, I forgot one more thing. Linux is a multi-process. Okay. So why Linux is so popular is the basic difference between your home computer and the Linux is, for example, 100 people can use multi-process. It's a kind of multi-threading, multi-process. 100 people can use Linux at a time, and multi-user, I can say multi-user, and you can, you do the user management and you can create a users and you can give it your, for example, there is an 100 GB, right? 100 GB Linux OS. You can create n number of users and uh, you can, everyone can log in at a time and you can, they can work on the Linux, they can work on their systems isolated, and they feel that there is an own system, their own system, and they can install the they can run the applications, and each and individual user, they can run the applications, they can do operations. So this is a kind of multi-user and multi-process, and so that is where the Linux is much more popular. And even in the Windows server you can do, but the problem is, as I told, Windows, if you keep your system, Windows, you can, if you keep your operating system, this Windows operating system for uh, 2 months or 3 months, and you come back, and if you do like this, it will go this side. When you do this side, when you go, when you do this side, when it will go, it will hung completely, it will go into the hung process. But in the Linux, if you, after 2 years, 3 years, if you go back and if you do ls-ltr or whatever you execute, it will execute perfectly. That's what the resilient was uh, compared to Linux and Windows. And hope you understand till here. And any questions till now? If you are quiet, I doubt you people are understanding or not. Anyone? So you understood or not? Whatever we are discussing it till now.
Yeah, we are getting.
Sorry.
Hello. Yeah, I am little but late, but
Yeah,
the
yeah,
last part, like shell scripting, commands, and environment, these are parts very clearly understood.
yeah, yeah. Any doubts on thanks, Anaga. So any doubt? I hope no doubts on Linux architecture. So you need to know how it interacts when you enter a command, how it interacts with the kernel and how you get the output. So this is something which you need to understand, and hope you people got that point, right? So it is bit important because when you start working on the Linux terminal, you shouldn't know what happens in the backend, right? So
Right.
that's a bit. I mean, and now coming to the interview questions. So first question, they will ask whether to test your real or have you worked really into the system or not. they will ask is how do you check the uptime of the server? Okay. And how do you check which kernel version is it is? And we will discuss that those commands in the next class, or when we install a Linux server. When I think after 2 to 3 classes, we will install we will install the Linux server in the EC2, and then we are going to work on. We'll see all the commands, how it works, and we can interact with the kernels, and those all things we can do, right? And also the question, which types of as I told, as I covered in the previously, like what type of instance you have worked on, right? So that is one question if they want to test you in the real time. And also they will ask you the basic regarding this one. I mean, whatever the topics we had discussed, they might ask you uh, what are the distributions you have worked on. So this is the basic question. If you're going for a Linux interview, or what if you want to choose your career into Linux interview or whatever, they will ask you what is a, I mean, I mean, on which Linux, which Unix you have worked on. What is the Linux version you have worked on? Got it? Those are the some of the types of questions they will ask, and I'll tell you the divine versions as today. I mean, you can tell in the I mean, I mean, you can speak in the interview, or you can tell them what versions you have worked on. Okay. So okay, divine is something we have. 13 is the current one, 13.1. And you can tell them that instead of saying the latest one, you can tell them I had worked on 12 or 11 version, right? So, and coming to Ubuntu. So Ubuntu, it starts from, I mean, the latest one, it's running around, I think, uh, 22, 22, or I think 25. Okay. So you can say I have worked on 24 or 20, 24 and 22. So these are the versions you can say when anyone asks. So what are the Ubuntu versions you had worked on? You can say 24 Ubuntu and 22. And coming to Red Hat, this is very important because Red Hat is something you have the present version, I think 10, I think so, the latest release. So you can say I started working from Red Hat 6, Red Hat 7, Red Hat 6, Red Hat 7, Red Hat 8. I had worked on those and all versions. So tomorrow we'll discuss what is the difference between Red Hat, because you can, when you say I had worked on Red Hat 6, 7, 8, the first question they will ask you is what is the difference between Red Hat 6, 7, 8, right? So you should know that basic difference between the Red Hat 6, 7, 8. As and one more thing just want you to know. So the difference between Red Hat 6, 7, 8 is, what do you think it will change? First thing, it will change kernel, obviously, right? Because kernel uses all these things. If kernel upgrades, then only these all things the core OS will upgrade, right? The kernel, in that way, you can correlate your answers and you can easily tell. For example, you can say kernel upgrade will be done, and sorry, not this. And we had file system, so that also had been upgraded to the next version. So it's, for example, ext2, ext3, ext4. I'll tell you those things. Those are kind of file systems. We'll cover that one. So that is how you can tell them that user, I mean, file system has been upgraded, and process management has been upgraded. So, and kernel has been upgraded. And so that is how, like, I mean, you can, the hard disk, and so these all things you can easily tell the interview that these are all the things had been upgraded in Red Hat 678. The difference between the Red Hat 678, like that, right? The current version is 10. Okay, Red Hat, and yeah. So CentOS is something you can CentOS stop supporting. I think so. I mean, those are the end of life. We call it as an end of life. It had 7 and 8, but I think you can remove this because it had stopped the supporting. CentOS got, I mean, stopped the supporting, and so you can say these things. Okay, so these are some of the things. If they want you to test in the real time, they will ask what are the versions you have worked on the Red Hat or Ubuntu or Debian. Okay, and we'll speak about the issues like kernel issues, kernel hung issues, what happens when kernel went into hung state. So these all things we'll discuss in the next class. So any doubts till here, or hope everyone is clear, right? So if you have any doubts, I'll share this one. I'll share this Linux first class in the, I mean, I'll share this material with you people. Okay. Yeah. Hope everyone is clear. Then you have 2 more minutes. Any doubts you can ask me. Yeah.
No, sir.
Thanks. Thank you. Hope everyone is clear till here. And tomorrow we are going to start uh, which is very, very important, boot process, Linux boot process. So most of the interviews they will ask, I mean, if they are more of Linux administration, they will ask you. See, in the outside now, how it is you don't know till you enter the environment or till you enter the company, you doesn't know what is going to happen, what the work is going, they are going to give. For example, they will say that DevOps, they will say CI/CD, they will say this Terraform, MLOps, everything they will say. But if they have, if they are having, I mean, if they're having hundreds of Linux servers and you need to manage them, obviously you need to step into, I mean, you need to show up and you need to step into that and you need to work on. You have no right to say that, no, I don't, I only work on DevOps, I don't work on Linux. So that is not my cup of tea. If you cannot say that, that is the problem in the this kind of DevOps world. So whatever the work you're going to get, you need to do, and that is how you have to come up. If you feel that it's not going to work out, for example, they have given the work on the Linux and which you are not comfortable, so what you can do, so you can enhance your skills and again you can try the interview outside till you get satisfied with the work life, I mean, till you get the satisfied with the technology. That's what, that's the only. And in the next company also, they will do the interview on the DevOps technologies and they might give you on the Linux administration. So no one can predict, or that is the biggest problem in this culture. So no one can predict what the work you're going to get once you deployed onto the resources as a resource, or once you deployed into the project, right? So yeah. So tomorrow we'll discuss about the Linux booting process and Linux, the file system hierarchy, how the file system hierarchy will be there. And so we had some of the services, daemon services and all. And so those are the things we'll discuss tomorrow. Okay. Okay, guys, then got to leave. Thank you. Bye.
Thank you.